in problems like this, we have two separate trigonometric functions within our equation. So what we need to do is get them the same. We need to have either all sine functions or all cosine functions. Because we've got the cos squared term, then actually we'll use these identities. And you remember there are two others that involve the cot and the secant and so on. And so in this particular case, this is going to come in handy because looking at this, you can replace cos squared theta with something. If you move the sine squared theta over the other side here, then we can substitute sine squared theta instead of cos squared theta here, and then we'll have all sine terms, and we've got a similar problem to the one we just looked at. So that's the way to approach it. See if you can work it out for yourself. The solution appears below. So first step is to say cos squared theta therefore is 1 minus sine squared theta. So in our particular equation we can replace cos squared t with 1 minus sine squared t. Plus 3 sine t minus 3 equals 0. And then we'd expand out the brackets. 5 minus 5 sine squared t plus 3 sine t minus 3 equals 0. Now collecting like terms, 5 minus 3 is 2. So we've got minus 5 sine squared t plus 3 sine t plus 2 equals 0. Not essential, but at this point I would actually multiply through by minus 1 to get rid of the negative 5 here and make that positive. That will help, I think, when we look at substituting into the quadratic formula. So 5 sine squared t minus 3 sine t minus 2 equals 0. So now we have a equals 5, b equals minus 3, c equals minus 2, and we're going to substitute those into the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Just being a bit careful of signs when we put them in. So x equals minus b. Well, b is minus 3, so minus 3 gives us plus 3. Plus or minus the square root of b squared. b is minus 3, minus 3 squared is 9. Minus 4ac. Well, again, we've got a minus multiplied by a minus 2, 4ac, because c is minus 2. So we end up with plus 4 times a, which is 5, 4 5s are 20, times 2, which is 20, all over 2 times 5, which is 10. So x equals 3 plus or minus the square root of 49 is 7 over 10. So x equals, remember what x is sine theta. So therefore, sine theta equals 3 plus 7, which is 10 over 10, which is 1, or 3 minus 7 is minus 4 over 10, minus 0.4. So sine theta equals 1 or minus 0.4, or sorry, should I say in this case not theta plus t, but t. So therefore t equals sine to the minus 1 of 1, which is 90, or sine to the minus 1 of minus 0.4 minus 24 degrees to the nearest degree. So now again, we've got to put these values of theta and into the wave function and look for all the angles that will lie within our range of 0 and 360 degrees. So the 90 is this one here. So that's the only one at the top there because the next one is beyond our range. But we've also got minus 24 degrees. So minus 24 is going to be around about here somewhere. So again, we're after that value and that value. So I'll leave you to finish that one off, and hopefully you'll come up with the following solutions. So t equals 90 degrees, 204 degrees, or 336 degrees.